Hello everybody, I want to give you a quiz 1 video. I'm going to talk about the quiz questions fairly quickly. May not solve all of them all the way out, but mostly just kind of setting up stuff, talking about why they might have been important and so forth. One of the things to keep in mind for these quizzes is one of their goals is to help me show you emphasis. Because ideally, you are reading the textbook, going through the examples in the textbook. Those examples are important. And going through your homework. And particularly in these review sections, chapter 1, 2, and 3 are review sections. There's a tremendous amount of material. So this quiz kind of allows me to focus you guys a little bit more. And if the quizzes don't go great throughout the term, keep in mind that the tests are worth the vast majority of our points. The goal of these quizzes is really a communication tool, so I can send some emphasis to you, and you can see where you are within those emphases. There's a word there somewhere. So let me go through some of these real quick. One of our most fundamental skills for lines. The order which you got these questions may be a little different. The system randomizes them. But one of them should have been, given a pair of points, make a line. This is a quite fundamental skill. Given the point -1, -2, and the point -8, -5, being able to make the line that goes through that pair of points is critical. You should expect to see this on test after test after test. To do that, we have to remember how to find first slope. Your good y2 minus y1 over x2 minus x1 for slope. One of the things I always recommend doing with this, just to keep yourself straight, is label your points. You got x1, y1, and x2, y2. Labeling them will help you not accidentally reverse their order and get your sign the wrong way. So according to the labeling, we've got -5 minus -2, careful with those negatives, over -8 minus -1. So -5 plus 2, -8 plus 1. So what, -3 over -7? Or a slope of 3/7. So slope of 3/7. How you build your line from that kind of depends on your background, what tools you like to use. You can use slope-intercept form directly. I like to use a version of point-slope form, whichever you prefer. So y equals mx minus x1 plus y1. You might have played with this tool with the y minus y1 over here. It's the same tool. So whichever tool you prefer. Y equals our 3/7. X minus the x1. We could really use either point, but since I've labeled it x1, I might as well use it. X1 is -1 plus our y1, -2. Simplify it. X plus 1 minus 2. Now this would be considered to be in point-slope form. We want it in slope-intercept form because that was what we were asked for. So simplify it. 3/7 x, distribute your 3/7 plus 3/7 minus 2, put that 2 in common denominators, 14/7, and get a nice y equals 3/7 x minus 11/7. Again, there are other ways to have done that problem using directly point-slope form, directly slope-intercept form, or using the other form of slope-intercept form, point-slope form, whichever tools that you want, as long as you are ending up here. Again, fundamental skill. You'll be asked to do this over and over again. Building lines from data is a key skill. The truck problem. For those of you who were looking on my website, you'll notice that this truck problem there's a video about this truck problem on the website. This truck problem is a linear application problem. So your section 2.2 on linear applications had this type of problem in it. You've got a section on learning linear skills. In those linear skills, you'll be doing all sorts of applications. So a lot of times with the word problems, it's very easy to feel we didn't do any word problems with trucks. Well, it may have been a different metaphor, but it's still linear application problems. So we have a highway and an on-ramp. A truck gets on this highway going, in the one they gave me, it was 60 miles an hour. 5 minutes later, a car gets on. That's a weird looking car. Anyway, the car is going 69 miles per hour. And this happened 5 minutes later. And you're being asked, when does the car pass the truck? So how much time? So I'm going to let t equal time till car passes truck. So in that time period, the car will have gone 69 miles per hour for t hours. Probably won't take hours, but how distance traveled is rate times time. So rate times time. That distance, when they pass each other, the distance the car has gone should be equal to the distance the truck has gone. So that should be equal to the truck's rate times time. But the time for the truck is different. The truck has been going for an extra 5 minutes. So the car is going 69 miles an hour for t minutes, or t hours technically. The truck has been going 60 miles an hour for t plus 5 minutes. And of course, 5 minutes is 1/12 of an hour. When those two things are equal, the car and the truck will be in the same position. So then solve. If you want to see more on that problem, check out the video on my website. My number 3 here is the rectangle problem. Again, the fact that it's a rectangle versus something to do with money or finance versus something to do with, filling jugs of water, whatever the metaphor happens to be, this is a linear relationship, and you're modeling that linear relationship. So the length of your rectangle is 2 centimeters less than twice the width. So if that's the width, and this is the length, that length is 2 less than twice the width. So we have that relationship. We're asked about perimeter. Perimeter is 2 widths plus 2 lengths. Perimeter being all the way around. All the way around we have 2 widths and 2 lengths. Now our lengths, we were told, are 2 less than twice the width, so the 2w minus 2. And this is supposed to be equal to, in my example, 26. So 26 is equal to 2w plus, distribute that, 4w minus 4. 26 is equal to 6w minus 4. So 20, add the 4, add the 4. So, oops, how about 30? Is equal to 6w. Divide the 6, and w is equal to 5. So the width has to be 5. The length is 2 times w minus 5. So your length is 2 times 5 minus 2. I think I said 5, sorry, 2. So your length is, 10 minus 2 is 8. Excuse me. So your dimensions are 5 by 8. On an exam, by the way, any word problem you've ever done, any application problem you ever do, always should be answered in a sentence. On the online questions, they kind of put the sentence in there, but you should be writing the width is, what was it, 5? 5 centimeters. With units in context, the length is 8 centimeters. Don't let the fact that the computer kind of puts those sentences in there for you get you in the habit of not expressing your answers in sentences. Word problem answers should be expressed in sentences. I will expect that on your exams, and you will be penalized for not putting your answer in proper context. Okay. Number 4, you had some of these on your homework, some solve equations. So solve given the equation, solve it. This is also kind of the big background skill. We're not going to be spending a lot of time learning basic solving techniques. You are coming in here ideally having fairly strong solving techniques. I expect those techniques to need some strengthening, and that's why we're practicing them. But be sure if you need more practice with them, you get them. If you're having a lot of trouble with your solving techniques, come in and talk to me. So generally when you're solving, you want to try to simplify each side as much as possible before you do anything else. So I'm going to distribute that 5 and collect some like terms over here before doing anything else. So how about add that 10x over? So 6 equals 15x, really? Oh, that's a big number. Divide the 15 off, reduce this fraction, so what, divide by 3, so 2/5. So it looks like x equals 2/5. Now again, if you're having trouble with these, or if you're making little mistakes on these, like I could have made a little mistake in there somewhere, distributing not quite right. Don't let that stress you out too much. As long as your general solving ideas are good and strong, you're getting the details right more often will get better. If this is like, I don't know what happened here, then again, come let me know, and we'll talk about how to get your skills strengthened back up. The cone problem. This cone problem really is specifically from your reading, from 2.2, one of the examples. So this is a good question, is a good reminder about making sure you're reading that textbook and looking at the examples in that textbook. Because to be able to do this problem, you have to work with similar triangles. Similar triangles are a linear relationship, which is why it's in this section. But you would have been more apt to be ready for that if you'd made sure you'd read the section. Not that it's an easy problem either way. One of the things you'll have to get used to, particularly with Math 111, we're talking about taking the skills that you have and making them more flexible. So you will often see word problems that will come at your material from a slightly different direction. So it may often feel like we've never done problems like these before, but it's using the similar types of skills, relationships, and thought patterns and having you push them to be able to use them in maybe unfamiliar scenarios. So this is why practicing particularly lots and lots of application questions, more than you're just assigned. Go into that textbook and do application questions like crazy, because that's where this material is headed towards, and that's what most people need to work on. So real quick, you're given the volume of a cone. A volume of the cone, by the way, is a nice relationship to know. If I want you to have something like the volume of a cone or a sphere or something like that, I'll give it to you. Areas of circles, perimeters of rectangles, things like that, I expect you guys to know. Some of the other conic sections I won't expect you to know. They're good to know, though, for the stuff that's coming up in your mathematical career. So, equation for the volume of a cone. Now, you're given that this relationship of the overall cone is 5 feet by 16 feet. Well, that's what I have in my problem. Some of the different problems change it. And you're asked how much volume is in the tank when this is down to 9 feet. Well, the triangle that's right here and the big triangle here have the same proportions. They are similar. So this radius of that small cone we can find by setting up a linear relationship between this ratio and that ratio. That 16 feet is to 5 feet should be the same ratio as 9 to whatever the radius is. And you can set this relationship up in a couple different ways. You could have said 16 is to 9 as 5 is to r. You'll end up with the same relationship either way. And we can solve this relationship. You can use your old property of proportion. Some people call it cross multiplication. So 16r equals 45. So r equals 45/16. So that gives us our radius. Our height is 9, and you can put that radius in there, that height in there, and solve for volume. The key to this problem is setting up your relationship in your similar triangles. So again, some of us have more similar triangles in our background than others. That's okay. Make sure similar triangles is something that you look at, and you will find some examples in the 2.2 textbook homework, just that section in the textbook, and the reading for section 2.2. I do want to make sure that you're hearing that you want to be reading that textbook, looking at the examples in the textbook, and especially for application problems, go into the problems in that textbook section. Find neat word problems and work them and play with them. Your online homework should not be the only problems you ever work. If they are, it's not going to be enough. You need to be spending that time diving in and playing around with those problems. Okay, let's see. A couple of these left. Trying not to make this too long for us, but I'm trying to give you some information too. Number 6 there is a problem from, I think it's 2.1. Might be 2. I think it's 2.1. It's just a problem on linear equations. If you've got a linear equations are of the form, y equals ax plus b. And the question is asking, if you set this equal to a particular value, ax plus b equals 0, how many solutions might this have as long as a isn't 0? And it's a linear equation. Linear equations are lines. They look, like that, or like this, or like that, or whatever they might look like. How many x values might make this true? Linear equations can only ever have one solution. It only crosses the x-axis in one place. This one will cross the x-axis eventually somewhere. The reason the problem says don't let this a be 0, if this a is 0, then you have a strictly horizontal line, which is never equal to 0. So as long as this isn't 0, it's going to cross at some x value, and that x value will be your one solution. This is going to be important because as we start dealing with quadratics in chapter 3, that x squared means we might have 2 solutions. The x to the third might have 3 solutions. X to the fourth might have 4 solutions, and so on. So how many solutions we might have from a polynomial is a significant aspect of some of the things that we're doing. This difference quotient problem, that difference quotient was actually, I think, section 1.4. But this is a section, again, reviewing your ability to work with functions. And again, there are some great examples with this in your reading. But given a function, I think this one is f of x equals 3x to the third, you're asked to evaluate the difference quotient and simplify. So you're just evaluating this expression. This expression says, like if it was like f of 5, you'd put a 5 in. If this was minus f of 4, you'd put a 4 in. This is f of x minus h. So what goes in here is x minus h. 3 times, x plus h, x plus h to the third minus f of x, well, f of x is just this, 3x to the third all over h. So from the perspective of evaluating the difference quotient, that's evaluating the difference quotient. Now you will tend to want to simplify these. This one's a little bit on the nastier side to simplify, because you want to simplify everything that you're working with. So, for example, if you want to simplify this, you'd make sure to FOIL this out. It's to the third power, so you'd have to multiply 2 of them together and then a third. You would get x to the third plus 3x squared h plus 3xh squared plus h to the third, knowing Pascal's triangle helps a lot with that, minus 3x to the third all over h. Distribute that 3, and you'll get a nice 3x to the third plus 9x squared h plus 9xh squared plus 3h to the third minus 3x to the third all over h. You'll notice that these 3x squareds cancel, and then there's only h's left here, so that h will cancel with one of those, and one of those. So you'll end up with 9x squared plus 9xh plus 3h squared. So there's a lot of your algebraic manipulation that you're trying to knock the rust off of early in this section. So there's nothing about this that requires you to know the difference quotient, what it is, its history. This is actually a form of slope that we use to define first term calculus. So those of you going into calculus will see this a lot. But also in your chapter, in your section, there's several examples of it because it's a nice way to practice manipulating functions. So this is a good tool for you to look at and play with. But it's also an example of, given a function and some evaluation tools, you know what f of stands for, and being able to practice putting these things in place is an important set of skills that we're going to need as we go along. In that similar section, and you had some homework problems on this, with the average rate of change, given a function, f of x equals the square root of 2x minus 7, for mine in this particular example, finding the average rate of change between x1 equals 4 and x2 equals 6. Now, I said this difference quotient was a form of slope. It really is. This is a y value. It's a function value, so it's a y value. And that's a y value. So it's the difference between two y values. For slope, this should be the difference between the x values. But if you look at the inputs up here, the difference between the x plus h and the x, the difference between those inputs is h. So this really is a change in y over a change in x. It's a slope argument. Again, that's why it's in our section on lines and slopes. Average rate of change does a similar thing for this function. It's a square root function, looks about like that, roughly. Again, we should know what things like square root functions look like. From 4 to 6, to find the average rate of change between those 2 points, we find the slope of the line through those 2 points. It's called a secant line. And again, you read that in your section. So how do we find the slope of any line? You find the slope of the line by taking the difference in the y values. This might not look as much like y2 minus y1, but in function notation, it's y2 minus y1. One output minus the other output over the difference in the x values. Now they call this in your section your average rate of change formula, but it's just slope. Y equals y2 minus y1, x2 minus x1. Just argument for slope. So f of 6 minus f of 4 over 6 minus 4. Be careful, you're not taking 6 minus 4 on top. You got to put that 6 in. 2 times 6 is 12. 12 minus 7. What's 12 minus 7? Is that 5? So that would be the square root of 5. That's kind of annoying. Oh well. Minus, put in the 4. 2 times 4 is 8. 8 minus 7 is 1. So the square root of 1 over 6 minus 4 is 2. So you've got square root of 5 minus 1 over 2. If you're asked for a decimal approximation, give a decimal approximation. If not, that's your value. Sorry. And again, this is slope. Just like this is slope. Just like the one we started with the line. Just like this is slope. So we want to kind of be making some of those connections. Okay. Last bit here. Almost last bit. Evaluating this function. So you're given a little graph here. I know this is hard to see in the scale, but that graph, you're asked for the solution for f of x equals -1. You're trying to find what x equals. Well, f of x is a y value. So where's the y? -1. You go on your graph, go over to -1. -1 seems to happen. Again, follow it kind of ideologically, but I went from -1 over. -1 seems to happen when what y is about, well, it looks like 3. So when x is 3, looks like we're getting a y value of -1. Always remember that you can click on that little magnifying glass there, magnify this out, and use your cursor to help you find what points are. Where is f of x equals 0? When x is what? Well, f of the function is 0. What's its x-intercept? Its x-intercept is right there. If you zoom in on that, you'll notice that happens at 2. F of x equals 2. When x equals what? Well, the function values at 2 is happening right there. That looks like -3. So it's just finding the points. Now, if they were giving you the x values and finding the y values, you'd see things like, find f of 5. You'd go to 5, figure out what the y value is, and give that y value. But you're being given the y values and asked for the x's, so just read the chart backwards. Practice those, play with those. Last one, this solving. Really we have to make sure we're practicing the solving. The big thing I would recommend with this problem is that you remember your clearing fractions. A skill, ideally, that you've learned somewhere in your past. It's going to come up a fair amount, so we want to make sure we have it. The thing that makes this problem difficult is we have all these fractions. I don't want the fractions. So what a common denominator would be, if we were to build common denominators, would be 6. Well, I don't want to go to the trouble of building common denominators. But if we multiply everything by 6, this 6 times 6, the 6 cancel, give me a 5. 6 times the 1/2 will give me a 3 times the d minus 3. The 6 times the 8/3, the 3 will divide by the 6, leaving a 2, times 8 is a 16, times 4d minus 5. Be sure that this 6 doesn't distribute to both of these terms as well, because be careful, this is one term and this is one term, so that 6 goes here once, we're multiplying it by the 1/2 because it reduces, and the 6 goes here to this term once, we're multiplying it by the 8/3 to get the 16. Then do your distributions and solve. So clearing fractions is a very important skill to practice. It's an easy one to not have used often enough. We will use it quite often, and it's one of the more handy general solving skills. So it's a really important thing to have in our bag of tricks. If you have any questions on these, let me know. Again, remember, most of our overall score by the time we're done will come from our exams. I want to use these quizzes as good communication tools. So if you have questions on them, let me know.